in this example, it's given that 1 plus x to the power 5 multiplied by 1 plus x to the power 6 is equivalent to 1 plus bx plus 10x squared plus whatever comes next plus the last term, which is a to the power 6 x to the power 11. And we are required to find the values of a and b, which are integers, and where a is not equal to 0. So the first step will be to expand 1 plus x to the power 5 up to the term in x squared, because if you look at what that is equivalent to, is stops up to goes up to the term in x squared, and of course the last term. And we shall do the same for 1 plus ax to the power 6 and then multiply the two products. So the first step, which is step 1, is expand 1 plus x to the power 5 up to the term in x squared and the last term. So what I mean here is this. 1 plus x to the power 5, and let's assume this is a non-calculator question, which means you need to use the Pascal's triangle. So the coefficients are 1, 5, 10, 10, 5, 1. But also remember that the powers of 1 are decreasing, and 1 to power anything multiplied by anything will just be what it is. So we shall just focus on powers of x here and the coefficients. So the first term here will be just 1. The second term will be 5x. And the third term will be 10x squared plus whatever comes next, plus the last term, which is x to the power 5, because the highest power of x will be 5. All right. The reason is the powers of 1 really do not matter here. Okay. The powers of 1 will just be 1. So the most important thing is the coefficients and powers of x as you expand this. Okay. It's actually an easier expression to expand. Okay. Step 2. We are going to expand 1 plus x to the power 6 and we are going to expand up to the term in x squared as well, because if you look at these guys here, they stop up to the term in x squared. So expand that up to the term in x squared and the last term. So what I mean here is this. We are going to have 1 plus ax to the power 6 being equal to, and the coefficients again are here. Okay, 1, 6, 15, 20, 15, 6, 1 from Pascal's triangle. So, and because powers of 1 really don't matter, I'll just focus on the powers of ax and powers and the binomial coefficients. So we have 1 plus 6 ax, where 6 is the binomial coefficient, plus 15 ax squared plus whatever comes next, plus the last term, which will be ax to the power 6. So that will give us, if we simplify this, that will be 1 plus 6ax plus 15 a squared, x squared, plus whatever comes next, plus a to the power 6, x to the power 6. So at this stage, we can now find the product of the two expansions, and we need the terms up to x to the power 2 and the last term. Okay, so that will be our step 3. So step 3 is find the product of 1 plus x to power 5 and 1 plus ax to power 6. And just remember that we need terms up to, so we need terms up to x squared and the last term. Okay, so what I mean here is the first expansion that we had was this one, 1 plus 5x plus 10x squared, which is here actually in step 1, 10x squared, plus whatever comes next, plus x to power 5. And the second expansion, which is right here, 1 plus 6ax plus 15 s squared x squared plus whatever comes plus a to power 6 x to power 6. Now remember here we just need the terms up to x squared. So when you expand this, we don't need powers terms in x cubed, in x to power 4. No, we just need up to x squared, which is actually easier for us. So what we shall end up with here will be 1 multiplied by 1. So just 1 by 1 here. I'm just multiplying them out. And 1 multiplied by 6ax plus 1 multiplied by 15s squared x squared. And that's it. Can continue. Now move to the next term, which is 5x. So 5x multiplied by 1 plus 5x multiplied by 6ax plus 10x squared multiplied by 1 plus, of course you'll have other terms in between, and the last term will just be x to power 5 multiplied by a to power 6 x to power 6. Okay, now if you simplify this, you'll end up with 1 plus 6ax plus 15 a squared x squared plus 5x plus 30 ax squared plus 10x squared plus other terms in between, plus the last term, which is a to power 6 x to power 11. We can group terms in x to power 1 and x to power 2. So what we can have here is 1 plus 6a plus 5 x plus 15a squared plus 30a plus 10x squared plus whatever comes next, plus the last term, which is a to power 6 x to power 11. So at this stage, and from the question, we know that this expansion is equivalent to this one here, this expression. So, and we want to find the values of a and b. So that would now be my step 4. Okay, I'm now on step 3. Yeah, so my step 4 will be Find the values of A and B by equating the corresponding terms. So step 4, find values of A and B by equating corresponding terms. So let's start with the coefficients of x. So our coefficient of x is this one here, and if you look at the expression above, it's b. So basically we can say that 6a plus 5 is equals to b. Let's move to the coefficients of x squared. And for the coefficients of x squared, which is this one here, you have 15 a squared plus 30a plus 10 is equal to, now if you come over here, that will be equal to 10. So this should be equal to 10. Now our goal, remember, here is to find the values of A and B. So we just need to find out of solving this equation. So anyway, 15a squared plus 30a will be equal to 0. Let's factorize out 15a. So that will be a plus 2 is equals to 0. So either a is equals to 0 or a is equals to negative 2. But we know that a cannot be equal to 0. And this is from the condition in the question, right? A cannot be equal to 0. So which means that the value of A is negative 2. So we can find the value of B by just plugging in negative 2 in the first equation that we had above there. So so from 6a plus 5 is equals to b, right? We have 6a plus 5 is equals to b. We'll just plug in the value of negative 2 in place of a. So 6 multiplied by negative 2 plus 5 is equals to b. So negative 12 plus 5 is equals to b, and therefore b will be equal to negative 7.